So, hello student, this is your physics teacher and welcome back to the physics class. As today's topic that you can see regarding grade 11 is the topic of projectile motion. Okay, here is the topic of projectile motion. So, projectile motion means something. We have studied many types of motion. In chapter number 3, we have studied about the motion in a straight line. But here in chapter 4, since this is the last topic of our chapter 4, so we are studying about the such type of motion. Those are supposed to be in a plane. So projectile motion is also that type of motion which is studied in a plane. So here is the definition of projectile motion. Here, that according to this statement we can analyze that what is projectile motion. As you can see, it has been written there that when a body is thrown upward in a direction different from that the vertical, then it is acted upon by the acceleration due to gravity and moves along a curved path in a vertical plane. Such type of motion is called projectile motion. So in this case we are talking about the projection of the particle at some angle with respect to this horizontal, with respect to this ground. If we assume that this horizontal line is a ground, then we are projecting this particle, throwing this particle at some angle. It is not perfectly vertical we are throwing. We are throwing at some angle that may be in between this vertical axis and in between the horizontal axis. Okay, so here is the angle of projection which is theta naught, you can see. And at this angle I am giving the speed, initial speed to be u of our particle. And these are the two components of our speed that we will be getting after resolving this u. Okay, we will be getting after resolving this u along the horizontal and in vertical direction. So in this what we are going to do, we will be calculating different parameters in case of projectile motion. As we will be calculating the range, that from where the particle has started this journey and after covering this curved path it is falling, it has reaching some distance o dash on the other side. Okay, so this range, the distance in between the point of initiation and the point of destination of the particle. Okay, so this is the range. What is the maximum height that will be attained by this curved motion? Okay, so and the time period and the exact time of flight we will be calculating. What is the time which a particle needs to cover this entire path? So why the particle is doing this curved path? Why this particle is following the curved path? Because there is always a force of acceleration due to gravity which is acting in the downward direction on this particle. At every point on this curve, the acceleration due to gravity will be acting in the downward direction. Okay, and that's why although it is having some velocity along the horizontal and vertical direction, but after that also it is regularly, continuously experiencing the downward force, and that is due to the gravity. Okay, and that's why it is following this parabolic path. Okay, so we will be studying about the nature of this path also. We will be deriving the expression that will be giving that path of a parabola, and that's why we will be concluding that projectile motion is always in a form of parabola. It will show a parabolic path. Okay, so let's see. Let's talk about. So first thing what we are required to do here is that we will be resolving, because this velocity which we are having, that is the initial velocity, we are not knowing that what is the component of this velocity along x direction or along the horizontal direction, and what is the component of this velocity along the vertical direction, that we are not knowing. So let us try to calculate according to the previous knowledge of vector resolution. So for this triangle we can understand and we can better write that we will be applying the cos theta to get the horizontal component. Okay, so cos theta naught for this will be how much? Cos theta naught will be equal to perpendicular, that will be which component? This component. Cos theta will be based upon hypotenuse. Cos theta will be based upon hypotenuse. So base is what? Base is the ux component. And hypotenuse is what? Hypotenuse is this component, that is u. Okay, hypotenuse is u, that is the direction of the initial speed of a particle. And from here we will be getting the ux component that comes out to be u cos theta naught. Okay, and now similarly we will be applying sin theta naught. We will be applying sin theta naught to get the vertical component of the velocity. Okay, so sin theta is what? Perpendicular upon hypotenuse. Okay, so again applying such condition in this triangle. So sin theta perpendicular is how much? Vy component. That what we are required to find. Vy upon u. So uy comes out to be how much? U sin theta naught. Okay, this you will be getting. So now we are having each components of the velocity, and at every point such condition will be applicable. Okay, there will be some uy component here and there will be some ux component here like this. And this will be the direction of the speed in this case. So at every moment the direction of the speed will change at every point. Okay, but still there will be some horizontal and vertical component. But if we reach at this point, at the topmost point, at this point there will be only the horizontal component of the velocity. In this case what we will be having? There will be no vertical component of the velocity. Okay, so it will completely vanish in this case. So let's see. Let's start from here in a very basic way. Okay, in a very basic way and in a very from the very beginning. Let us start. So what we can say? We have to first. Our aim is to first calculate the nature of this path. What is the nature of this path? So for nature of the path, we have to derive one equation. We have to derive one equation that will be telling that what is the nature of this path. Okay, whether it is whether our equation shows the equation of circle, or whether the equation which we will be getting is showing the equation of a parabola, or whether the equation which we will be getting is showing the equation of hyperbola, what we are getting. So that will be decided according to the equation that we will be getting here after the derivation. Okay, so let's see first of all. So if we talk about the displacement of the particle, okay, if we talk about the lateral displacement or horizontal displacement of the particle, so which component is responsible for that? Only this component will be responsible for that. That is the ux component. Okay, that will be the ux component. That is the component of the velocity along the horizontal direction. So we have already calculated the ux component. Okay, that is the initial speed along the horizontal direction. So in t interval of time, if I am having the t interval of time, so in that case, what will be the displacement of the particle along the horizontal direction? Let us see. So displacement of the particle, if I denote the displacement of the particle by x along the horizontal direction, so displacement is equals to velocity along that and into time. So velocity I am having, that is equals to ux. That is equals to ux, and ux is equals to u cos theta naught into t interval of time. This what we want to calculate. And from here what we will be getting? From here we will be getting the time, and time is equals to x upon u cos theta. Now this time is very important. Now this time which we got is very important. Why it is very important? Because this will be helpful in defining the nature of the path that we will be calculating. So let us name this equation number 1. Okay, now we are having the time that was unknown to us in terms of the displacement along x direction and along the component of the velocity in x direction. This is what we have. Now we better know that 3 equations of the motion that we have studied in our previous chapter, and we have also seen its glimpse in the class 9. Okay, we have seen in its glimpse in class 9 also, and we have studied in previous chapter also, that is motion in a straight line. So according to that, the second equation of motion tells that about the displacement of the particle, that is s is equals to ut plus half at square. But if we talk about the acceleration due to gravity, if the particle is doing its motion under the influence of acceleration due to gravity, then in that case we better know that the a term, that is the acceleration term, which was coming in the second equation, is replaced by the g term, that is acceleration due to gravity. And we know that acceleration due to gravity is denoted by small g. So what will be the expression? What will be the expression for the height? For the height of a particle in t interval of time. That means we are talking about the second equation. At what height the particle will reach? Okay, at what height the particle will reach in that case. So in that case, what we will be writing? We will be denoting that height as we have denoted the displacement along x-axis by x. Similarly, the displacement will be, in this case, the displacement is both along the x-axis also and along the y-axis also. So now what we do? We do the calculation for the calculation of what? The height. At what height in t interval of time the particle is reaching. Here we have calculated the parameter x, the horizontal displacement. But what will be the vertical displacement in that case? So we will be using which formula? We will be using this formula, that is h is equals to ut minus half gt square. Because why I am writing this minus? Because this minus is just because of the presence of acceleration due to gravity, which will be in the downward direction. Okay, so s is equals to ut plus half at square has been replaced by this equation, where h is the height, at which height the object is reaching. So if I am talking about x and y component, so this height will be along in the vertical direction. So better to represent this height by y. Okay, better to represent this height by y component, as we have represented the horizontal component by x. Similarly, we are representing the height component, that till what height a particle has reached in t interval of time, by y component. So y is equals to, what will be the speed? What will be the speed regarding the vertical height? What is the speed which is responsible for a particle to reach that particle to a certain height? Will this speed have any contribution? No, because this has a contribution only in the horizontal direction. This do not has a contribution in the vertical direction. So this speed only, that is the vertical speed, uy, is having the contribution for the vertical direction. So instead of this initial speed, what will be using? We will be using the y component of the speed, because we are talking about the y height. So correspondingly, we will be using the y component of the speed, that is u sin theta naught into t, in t interval of time we are talking about, and minus of half gt square. This is what we can write according to the knowledge of equation of motion. Okay, and now we can substitute some further values which we have got. Okay, now still we do not have this time t in terms of theta naught and in terms of initial speed that is given. The initial speed may be something of an object that a person knows who is doing the experiment while throwing the object. So let us reduce this small t by the equation number 1. Okay, let us substitute the value of the small t from equation number 1. That means we will be getting y is equals to u sin theta naught into x upon u cos theta naught minus half g t square. Again t, instead of this t we will be substituting what? X upon u cos theta naught, x upon u cos theta naught ka square. This is what we will be getting. And this y component will be only telling that which type of the path we are getting here, as we have drawn here the path. But this path can be well proven according to the equation which we will be getting here, because we will be getting the equation of parabola. Okay, we will be getting the equation of parabola. So what we will be getting from now? From here what we will be getting? We will be getting what? From u, this u cancels out. So y comes out to be tan theta naught into x. Is it clear? Because sin theta upon cos theta is tan theta. Minus of half g x square upon u square cos square theta. Okay, so this expression we are getting finally. Okay, this expression we are getting finally, and this equation, if we have studied mathematics and if we have studied mathematics till class 10th only, then we can be able to understand that this equation tells about the equation of parabola. Okay, this equation tells about the equation of parabola, and that's why we draw while projecting any particle at some angle with respect to horizontal axis, we get a curve or we get a path of a moving particle in the form of parabola, because this y component comes in the terms of x and theta. Okay, in terms of x and theta, you can see here in terms of g. Okay, and it gives the expression of a parabola. Okay.